Hello everyone. This video goes over the Unit 4 Lesson 5A notes on double and half angle formulas. All of these double and half angle formulas that you see here are listed on your orange formula sheet. Oh, well, it might not be orange, I guess, but it's whatever color your formula sheet is this time around. Look at like number 17. You can see a bunch of variations, actually kind of important. So like if you look at like 17A, 17B, and 17, you'll see all these cosine 2x formulas. And I would probably put a little star by this one here, which I believe is formula 17. Out of these three, this one is the nicest one to use because it sets you up with common denominators. Sine 2x, we don't really have a choice. There's just one formula to use. You'll see like a tan 2x formula, cosine x over 2, so on and so forth. But look at tan of x over 2. We also have options for tan of x over 2. We have 1, 2, 3 choices. This is like formula 23a, 23b, and 24. I would put a star by this guy here. He is the easiest to use out of the three. I believe this is formula 23b. So the ones where you have multiple choices, if we're plugging in values from either a picture we drew or our 45, 45, 30, 60, 90 triangles, if we're plugging in numbers, I would use the starred formulas. Now, if we're solving identities, like our lesson 3 quiz, where it was the 10 questions where you have to show like the left side equals the right side, then anything's fair game because it just depends on what you're trying to accomplish. So again, I would only use the starred formulas for when I'm actually plugging in values. If you're solving identities, then any of the ones that would help you get to your end game would be the one that you would pick. So we just hop right into these examples. Again, I would have my formula sheet handy, or you can just reference the formulas above. But the first one says, find cosine of x over 2. So right away, cosine of x over 2, hopefully you see that's formula 18. So I will be using formula 18. And then they tell me cosine x is negative 31 over 81, and x is between 180 degrees and 360 degrees. This is going to be relevant in a second. You'll see why as soon as I write down this formula. So let's start by writing down the cosine of x over 2 formula, which if you look at formula 18 on your formula sheet, it says plus minus big square root of 1 plus cosine x over 2. So big square root of a fraction. Now clearly it's kind of nice. They already give me cosine of x. Cosine of x is just going to be replaced with that negative 31 over 81. It's the whole plus minus where this part comes into play. If this is x over 2, I need to figure out if this is going to be positive or negative. They give me this setup. So I'm going to say, okay, if 180 degrees is less than x is less than 360 degrees, which is given, they want x over 2. So if I want x over 2, I need to divide all of these by 2. Then I know that my x over 2, whoops, forgot the over 2 part. My x over 2 has to be greater than 90 degrees, but less than 180 degrees. So basically, if I'm solving for x over 2, and x over 2 falls between 90 and 180, this is in quadrant 2. This is in quadrant 2. And because of all star trig class, if I'm in quadrant 2, only sine is positive. I'm talking about cosine. So overall, this is going to be a negative. So negative because of that information. It's going to be negative overall because I'm in quadrant 2, and all star only signs positive in quadrant 2. So I'm just going to carry the negative throughout. So negative, big square root, 1 plus cosine x is given as negative 31 over 81. I'm going to have to expand my root all over 2. Now, it looks sloppy. You can't type this into your calculator. You're going to have to do it by hand with a common denominator. So if this is out of 81, I'm basically just going to make this 1 and 81 out of 81. So 81 out of 81 is a big fat 1, but that gives me my common denominator. So subtraction sign in front still. Here's the over 2 part. Here's my common denominator of 81. And I have 81 plus a negative 31. 81 plus a negative 31 is 50. At this point, a lot of people are they get stuck. They're not sure where to go. So I would say if this is a fraction divided by, I would write this as a fraction. and then hopefully it makes more sense. Make sure your root covers that, by the way. If you have a fraction divided by a fraction, you're going to multiply by the reciprocal. So make sure you actually flip it. This has been relocated, so I'm going to kind of cross it off. So now it looks like I have that negative in front. When I look at this, I see a 50 in the numerator and a 2 in the denominator. Like, listen, I could totally do 50 times 1, write it down. 81 times 2, write it down. But I like to simplify where I can. And since I have a 50 on the numerator and a 2 on the denominator, I can take this 2 out, and then that 50 becomes a 25. So basically 50 divided by 2 is 25. I still have the 81 on the bottom. And I know that since this is the square root of a fraction, I can do the square root of the numerator over the square root of the denominator. And I know the square root of 25 is 5. I know the square root of 81 is 9. So my final answer is -5/9. So these formulas do require a lot of kind of legwork with the whole common denominators, fully simplifying. If we ever get like roots on the bottom, we're going to have to make sure we rationalize denominators. So you just got to be careful. Watch your steps, watch for silly mistakes. Next one, find the exact value of 22.5 degrees. Well, anytime anything is 0.5, you're going to multiply it by 2 to get rid of the decimal. So instead of sine of 22.5, I'm going to say sine of 22.5 is the same as, if I double it and get 45, I'm going to think of it as 45 degrees cut in half. So first off, understand that I doubled it to get rid of the decimal, but these have to be equivalent. So I can't just say it's equal to sine of 45, but 45 cut in half is 22.5. And now this is going to be my sine of x over 2 formula. Sine of x over 2, where the 45 is going to be my x. So this is the sine of x over 2 formula, which is formula 19. And I am, in place of x, I'm putting a 45 in there. So if I write out formula 19, first off, there's that plus minus thing again. Big square root, 1 minus cosine x, but don't forget x is 45 degrees, all chopped in half. As for the plus minus, since I'm talking about 22.5, that's in quadrant 1, so it's going to be positive. So positive since in quadrant 1. Positive since 22.5 is in quadrant 1. So I don't have to worry about writing it down. I can just go ahead and do the math. Big square root, 1 minus. Now those of you that know cosine of 45, you can just write it down. If you know the little hand trick, you can get it from there as well. Otherwise, you're drawing your picture, which literally took me seconds. Cosine is caw. It would be 1 over root 2, but you need to get the root off the bottom, so root 2 over 2. So cosine of 45 is root 2 over 2, still that 2 on the bottom. Make sure this root covers the whole fraction. Again, with the common denominator, if this is out of 2, I'm basically just going to change that 1 to 2 out of 2. So I have this big square root. Here's this bottom part. Here's the over 2 on the bottom. Up top, I'm going to have 2 minus root 2 over my common denominator. 2 minus root 2 over the common denominator. Just like the prior one, I would put this 2 over 1. Make sure you draw that root down. Fraction over fraction, you're going to multiply by the reciprocal. Make sure you demonstrate that that moved, and make sure you flipped it. Now be careful here. Some people will be like, oh, this 2 on the bottom cancels that 2 on the top. That's not true, because you'd have to cancel a 2 from here as well, and I would need the 2 in front, and I don't have that. So basically, I have this big old square root. It would be 2 minus root 2 times 1, which is 2 minus root 2, over 2 times 2 is 4. And just like the previous example, how we had the square root of the fraction, and we broke it down to the square root of the numerator, square root of the denominator, same idea here. Kind of running out of room, sorry guys. Oops, erasable pens, this is why I like them. I'm going to do the square root of my numerator, which I cannot simplify that, but I can do the square root of 4. So my final answer is going to be the square root of 2 minus root 2, which looks ugly, but that's what it is, all over square root of 4 is 2. That's the final answer. Square root of 2 minus root 2 in the root over 2 on the bottom. So yes, you do fully have to simplify these problems. If at any point you think I'm going too fast, don't forget you can pause or rewind. Some people like to actually watch the notes, like write what I'm doing, and then they'll rewind. And now that they already have it all written out, they'll just watch it so they don't have to like keep watching what they're writing. They seem like they catch on quicker that way, but you do you. This one says sine x is given, and I'm in quadrant 1, and I'm supposed to find sine of 2x and cosine of 2x. All right, if they are telling me it's in quadrant 1, I'm going to draw a picture. Picture in quadrant 1. Since it's sine x, the angle is x. You know sine is so opposite of 4, hypotenuse of 5. This is my 3, 4, 5 triangle. That only works, by the way, if the 5's the hypotenuse, so be careful. Sine 2x, if I look at my formula sheet, this is formula number 16. Formula number 16. I like to call this plug and chug. I'm going to write out the formula. 2 sine x cosine x. And I'll plug in the values. I know sine x and cosine x are going to be fractions, so I'm going to write this 2 over 1. So it's also a fraction. That way all my numerators and denominators line up. Sine x was given as 4/5. And them wanting me to find cosine x is why I drew this handy dandy picture, because I can go to my picture and cosine is ca 3/5. Multiply all your numerators. 2 times 4 is 8, times 3 is 24. Multiply all your denominators. 1 times 5 is 5, times 5 is 25. Simplify if you can, otherwise you're done. Part 2 is cosine 2x, which remember we had all those options, but on the front page of the notes I told you to star formula 17. That's the easiest one because it will set you up with common denominators every time. That's why I like it. So the formula is cosine squared minus sine squared. Again, you're just getting that from your formula sheet. So take cosine, square it, take sine, square it, and then subtract them. Cosine, we just found ca 3/5. I'll square it in a second. Sine was that given. I could also get it off my picture, let's be honest. Square your numerator and your denominator. Square your numerator and your denominator. 3 squared is 9. 5 squared is 25. 4 squared is 16. 5 squared is 25. See how it set me up with that common denominator? That's easy. I like that. 9 minus 16 gives me -7. That's my final answer. If you go to use this formula 17 and you do not have a common denominator, then something's wrong. Like you messed something up, maybe your picture's wrong, or you accidentally, found the wrong trig function, but double check your work because something's wrong. Similar for the next example, it's just different formulas. There you give me sine, again, so, but this time I'm in quad 3. So I'm going to draw my little picture in quad 3 to start. 1, 2, 3, bow tie triangle. Sine x, opposite is 3, hypotenuse of 5. This is my 3, 4, 5. I will do the negative spaced off the graph. So graphing left gets a negative. Graphing down gets a negative. When you draw those pictures, make sure you catch your negatives. You're going to get the wrong answers. Tan 2x to start. If I look at my formula sheet, looking, this looks to be formula 22. So I'm just going to write down what I see. 2 tan x over 1 minus tan squared. All right, I know tan's going to be a fraction, so I'm going to make this 2 over 1. Got to line up my fractions. Tan is TOA, but do you see how I get a negative over a negative? So opposite over adjacent, negative over negative, that's going to be a positive 3/4. Positive 3/4. On the bottom, it's 1 minus whatever tan is, which we just found was 3/4 squared. Up here, I can go ahead and multiply. You can actually take a 2 out here as well. So like when I look at this, and some people hate this, so if you hate it, just go ahead and multiply, like do 2 times 3 is 6, 1 times 4 is 4. But look, if I go up here, 2 times 3 is 6, 1 times 4 is 4, I can take the 2 out, so I get 3/2. So do it on the side, or just think I'm taking this 2 out, so then that becomes a 2. I usually do these little notes, but then it gets sloppy, so if you prefer to do that work off the side, feel free. Either way, it'll save us time later if we write it as a 3/2 instead of a 6/4. On the bottom, I will get a common denominator, but I need to square this fraction first. 3 squared is 9, 4 squared is 16. Now I know I have to change the 1 into a 16 out of 16 for my common denominator. Looks like I have 3/2 over, out of 16, I have 16 minus 9, which is 7. Fraction over a fraction, I'm going to multiply by the reciprocal. Make sure you actually flip it and draw some type of line demonstrating that, you know, it did move. So let's see, I'm going to do like kind of this idea here where I did with 3/2. If I look at this, I'm like, oh, I see a 16 on the numerator, a 2 on the denominator. By the way, this is only working because I'm multiplying. But I can take that 2 out, and then that 16 would become an 8. And then nothing else will cancel down. So basically, I have 3 times 8, which is 24. And that 2 is now a 1. 1 times 7 is 7. 24 sevenths. If that's mind-boggling to you, how I keep, you know, cross-reducing like that, just do it as it is, and then you can simplify down at the end. It's not a big deal. The second part of this is tan of x over 2. So tan x over 2. Again, looking at my formula sheet, this is the one that we have multiples that we can pick from, and I told you formula 23b is going to be your easiest option. That formula is 1 minus cosine x over sine x. So 1 minus cosine, negative 4/5. Hopefully right away you are paying attention that this double negative is going to change into a big fat plus sign. So if you ever see this weird circle thing with a big fat plus sign, it's because it was a double negative. I like to catch that as quickly as I can so I don't make silly mistakes later. Sine x on the bottom, sine is so negative 3/5. Well, I'm going to need a common denominator here, so I'm going to change that 1 to 5 over 5, 5 over 5. So basically, my negative 3/5 is just hanging out on the bottom. My common denominator of 5 up top, I have 5 plus 4. 5 plus 4, that's 9. Fraction over a fraction, multiply by your reciprocal. And don't forget, anytime you multiply by the reciprocal, you're like, please, please, please let something cancel. It's kind of nice. These 5s cancel directly. And I will write this one out just because it's kind of getting sloppy. I'm left with 9 over negative 3, which is a negative 3. You could jump right from that to the negative 3, but just so you didn't miss it, that's where it came from. These last two are very similar, it's just different formulas. Cosine 2, inverse sine of 3/5. Just like in the last set of notes, the inverse sine, the inverse part is going to be a picture. So the 2's still on the outside. Just the inverse is going to be a picture. And then what's going to happen is, if that's a picture, then this will become cosine of 2. I'm going to call my picture x. So cosine 2, I'm going to draw a picture with this and name that triangle x. Also, inverse sine only exists in quadrants 1 or 4. 1 or 4. Since this is positive, I'm in quadrant 1. So I use the fact that I know where the inverse belongs, which is going to be 2 quadrants and only 2 quadrants, and then if it's positive or negative, to draw it exactly where it should be. So in quadrant 1, bow tie triangle, I'm calling mine x. Sine is so opposite. Hypotenuse, again, 3, 4, 5. They're trying to be nice by giving us these 3, 4, 5 triangles, because once they start having roots, it's even more work to simplify, but we're just learning it, so we'll get to those later. Cosine 2x, I'm going to use my formula 17, because that's the favorite. Cosine squared minus sine squared. So whatever cosine is, square it, minus whatever sine is, square it. Use your picture for your values. Cosine is 4/5. Sine is 3/5. Make sure when you square both your numerator and your denominator. Square both your numerator and your denominator. I picked formula 17 because I know if I'm doing it correctly, it will set me up with the common denominator. I have 16 minus 9, which is 7. 7/25. Last one, very similar. Try to keep them up at the same time so you can see. Just the inverse becomes a picture. And I'm going to call this x, so then that means I'm going to have tan 2x. Inverse cosine is either quadrants 1 or 2. Quadrants 1 or 2, and since this is negative, I'm going to be in quadrant 2. So drawing my picture in quadrant 2, bow tie triangle, calling mine x. Cosine is adjacent, hypotenuse. Again with the 3, 4, 5, but graphing left, catch your negative. Don't forget if you're graphing down to also catch that negative. I'm going to use formula 22, which is 2 tan x over 1 minus tan squared x. And at this point, it's just plug and chug. So again, the inverse becomes the x. That's the picture. And now we're just doing tan of 2x. I know tan x is going to be a fraction, so I'm going to put my 2 over 1. Tan, opposite over adjacent. 4 over negative 3, I'm going to put the negative up top. Just in case I have to do common denominators, it'll make it easier for me. So I'm going to just put the negative up top. I'm allowed to do that as long as the negative is being represented. On the bottom, honestly, it doesn't matter, because when I take that negative 4/3 and I square it. Guys, be careful here. Some people will be like, oh, that double negative changes to a positive, and that's not right, because I'm going to square this negative. That's going to go away. So that subtraction sign is still going to be there. So follow your PEMDAS. I got to do that exponent before I can, look at that subtraction sign. Up here, doesn't look like anything cancels. 2 times negative 4 is a negative 8. 1 times 3 is 3. Looks good. I'm going to bump this a little bit. On the bottom, 1 minus negative 4 squared is a positive 16. 3 squared is 9. I'm going to change my 1 to get a common denominator, so it's going to be 9 over 9. Looks like I have negative 8/3 over common denominator of 9. 9 minus 16 is a negative 7. Fraction over a fraction, multiply by the reciprocal. That moved. First off, this double negative, that'll become a positive. So double negative becomes a positive, and I'm going to reduce down. For instance, I know since I have a 9 on my numerator and a 3 on my denominator, I can do 9 divided by 3. So that 3 will go away. It's just a 1, but I never write the 1. And then that 9 became a 3. 8 and 7 have nothing in common. So again, double negative becomes a positive. 9 divided by 3 was 3. So I have 8 times 3, which is 24. That would be a 1. 1 times 7 is 7. I get 24 sevenths. If you hate that I did that step in blue, then you just do negative 8 times 9, write it down. 3 times negative 7, write it down. And then you simplify. I prefer to do it this way because I can do it without a calculator. I believe that's the end of the notes. So now you should be off going to work on some practice problems.